Hello friends, myself Rajendra Mahajan presenting my video on Fourier transform. Example evaluate integration from 0 to infinity of x square divided by x square plus 25 x square plus 25 multiplied by x square plus 49 with respect to x using Parseval's identity. Watch the video up to end. I am solving two examples on Parseval's identity. Given integral from 0 to infinity x square upon x square plus 25 into x square plus 49, we can, as integral from 0 to infinity of x upon x square plus 25 multiplied by x upon x square plus 49. I am splitting that x square as x into x. We know that if f of x is equals to e raised to minus 5x, then a Fourier sine transform of it as lambda upon lambda square plus 5 square and g of x is equals to e raised to minus 7x. Then its Fourier transform, sine transform, gs lambda as lambda upon lambda square plus 7 square. Then by Parseval's identity we have using Parseval's identity we have integration from 0 to infinity of two by pi integral from 0 to infinity fs lambda multiplied by gs lambda, and its integration with respect to lambda is integration from 0 to infinity of f of x into g of x. Substituting the corresponding values, we get 2 by pi integration from 0 to infinity fs lambda is lambda upon lambda square plus 5 square, gs is lambda upon lambda square plus 7 square with respect to lambda as integration from 0 to infinity e raised to minus 5x multiplied by e raised to minus 7x. Simplifying it with respect to x, we get integration from 0 to infinity of lambda square upon lambda square plus 5 square into lambda square plus 7 square with respect to lambda as integration from 0 to infinity, taking the addition of the power, we get e raised to minus 12x, and transferring that 2 by pi to right hand side we get pi by 2. Integrating this term with respect to x, we get pi by 2 as it is, no change. e raised to minus 12x divided by minus 12, limit from 0 to infinity. Pi by 24, cancelling minus sign by changing the limit. Upper becomes 0, e raised to 0 is 1, minus e raised to minus infinity. And therefore we get pi by 24 multiplied by 1 minus 0 as pi by 24 as the required value of that integral by Parseval's identity. This is the value of that first integral from or using Parseval's identity. Very simple. Once again go through all the steps carefully, watch it again carefully. If any doubt, please write in the comment box. Second example, evaluate integration from 0 to infinity of 1 upon x square plus 4 into another term as x square plus 36 with respect to x using Parseval's identity. To evaluate it by Parseval's identity, let f of x minus 2x and g of x as e raised to minus 6x. Then Fourier cosine transform of the first term is 1 upon or 2 upon 2 square plus lambda square or lambda square plus 2 square, and Fourier cosine transform of the second term as 6 upon lambda square plus 6 square. Then by Parseval's identity we have the result 2 by pi integration from 0 to infinity fc lambda multiplied by gc lambda d lambda as integration from 0 to infinity of f of x into g of x with respect to x. Substituting the values, we get 2 by pi integration from 0 to infinity fc lambda is 2 upon lambda square plus 2 square multiplied by 6 upon lambda square plus 6 square d lambda as integration from 0 to infinity e raised to minus 2x into e raised to minus 6x. Transferring 2 by pi to other side, we get integration from 0 to infinity of 1 upon lambda square plus 4 into lambda square plus 36 with respect to lambda as 6 to the 12 and 12 to the 24. Therefore, pi by 24 as the outside term, and integration of taking the addition of power, we get e raised to minus 8x. With respect to x, integration of that term is e raised to minus 8x divided by minus 8, limit from 0 to infinity, pi by 24 into 8. That term is 272, and changing the limit we get e raised to 0 minus e raised to minus infinity. E raised to 0 is 1, e raised to minus infinity 0, and therefore the value is pi divided by 272 as a required value of that integral obtained by application of Parseval's identity. A second example from this video. Therefore, go through all the steps once again, check every step carefully. Please like my video, share it, as well as subscribe to my channel, and to receive the notification of such type of new videos, please press the bell icon. Thank you.